Alright, so we're going to look at real quickly one way to derive the unit circle, which is really, can seem overwhelming, but it's really pretty simple because there's a lot of patterns involved in it. And if you can reduce fractions, you can get the unit circle pretty easily. So what we're going to do is the unit circle is a radius of 1, and so it has a circumference of 2 pi. And so we're going to start looking at points that are on kind of the vertices, on where it crosses the intercepts, the x and y intercepts. And so if it's 2 pi all the way around, or 0 degrees, 0 radians all the way around, we put those points on and we start counting. We're counting by pi over 2's. So let me speed it up a little. So we get pi over 2, 2 pi over 2, 3 pi over 2, and then we would get 4 pi over 2, which reduces to 2 pi. The next thing we want to put on are the quarters, the pi over 4's. So I'm counting by 1/4 of a pi. The thing to keep in mind is that the points on the top here, over on at pi, down at the bottom, all my intercepts have to be counted again, because 1/4 and 2/4 is going to make up that half there. So we put those on there. I get pi over 4, I get 2 pi over 4, I get 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Alright, and I want to make sure that everything is reducing as it should, so I look at my 8 pi over 4 reduces to 2 pi. 6 pi over 4 reduces to 3 pi over 2. 4 pi over 4 is the same as 2 pi over 2, which is the same as pi, and 2 pi over 4 is the same as pi over 2. So I'm all good. I've done it correct so far. Now I put on the pi over 6's. And again, I want to make sure that I am counting all these vertices, these intercepts, that are, again, going to be my pi over 6's. So I get pi over 6, 2 pi over 6, 3 pi over 6 at the top, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. And again, those should reduce. So my 12 pi over 6, that's 2 pi. 9 pi over 6 is 3 pi over 2. 6 pi over 6 is the same as pi. And 3 pi over 6 is pi over 2. So it's all good. I reduced some of the pi over 6's to get me my pi over 3's. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So now I have all the radian measures on my circle. What I have to do next is put in the trig value. So I really have to know two things. If I know the first two coordinates, I know the rest of the circle. So that's root 2 over 2 is my pi over 4 values. That's easy. It's the same thing. The next one, the pi over 6 value, I have to remember that it goes root 3 over 2 and then 1/2. For my pi over 3 value, I just switch the order of those. So I have root 1/2 and then root 3 over 2. If I wanted something in the second quadrant, I just change the sign on the x values. So it becomes negative 1/2 root 3 over 2, negative root 3 over 2, root 2 over 2, root 2 over 2, and then negative root 3 over 2, 1/2. And so my sine value for 5 pi over 6 is 1/2. My cosine value for 5 pi over 6 is root 3 over 2. My sine value for 2 pi over 3 is root 3 over 2. My sine value, my cosine value for 2 pi over 3 is negative 1/2. So it allows me to get my values. Now let's say that I couldn't remember the root 3 over 2 and the 1/2. Well, all it is the 30, 60, 90 triangle moved around. So if I take a 30, 60, 90 triangle on my unit circle, that's 1, 1/2, and root 3 over 2. And so if I wanted to figure out cosine of this angle here of 30 degrees, that's adjacent and hypotenuse. If the hypotenuse is 1, it's just root 3 over 2. So that's the same as that value here. Sine is opposite over hypotenuse, which gives me the 1/2 right there. And I can convert my 30 degrees into radians, which is the pi over 6. It looks like that. So again, I can move this all around, get the unit circle fairly painlessly by reducing my fractions.